A smooth slope is inclined at 30 degrees to the horizontal. A body of mass 5 kilograms is released from rest at the top of the slope and reaches the bottom of the slope with a speed of 6 meters per second. Find the length of the slope. Okay, so the first thing you need to do is draw a diagram. So we're going to draw a slope of 30 degrees. We're going to put our body at the top here, which has a mass of 5 kilograms, so the force downwards would be 5g newtons. It has an initial velocity of 0 meters per second, and it's going to reach the bottom of the slope, same mass and same force acting downwards, with a final velocity of 6 meters per second. We should note that the slope is smooth, so we don't have to think about any energy to overcome the resistance. So we have to find the length of it travels, basically the length of the slope. So the energy at the top of the slope here, point of release, will be equal to the kinetic energy, initial kinetic energy plus the initial potential energy. So the initial kinetic energy is given by a half mv squared. Normally we write half mv squared, but we're talking about the initial velocity here, so it's going to be half mu squared, plus the potential energy, which is mgh. Now h will be the height, that it is the vertical height from the bottom of the slope. So that's going to be half times 5 times 0, so that's going to be nothing, plus 5 times g times the height here. Now the height here is given by s sine 30, which is good because that's what we want to find. We want to find this length here, s. So it's going to be s sine 30 for basic trigonometry. Now the sine of 30 is a half, so that will just give me 5 over 2g s joules. Now we should just leave it as that. We shouldn't worry about the g. We'll deal with that at the end. Right, if we just draw out the diagram again, so we can now have a look at the energy at the bottom of the slope, which is here. Okay, that will be the final kinetic energy plus the final potential energy. So it's now travelling at 6 meters per second when it hits the bottom of the slope, so it's going to be a half times 5 times 6 squared. But the potential energy will be nothing because it'll be 5 times g, there'll be no vertical height, so it'll just be nothing from this. So 6 squared is 36 times 5, and then divided by 2 will give me 90 joules. Now, by the principle of conservation of energy, the initial energy will be equal. The initial energy here will have to be equal to the final energy here. There's no friction here involved. It's a smooth slope. So the initial energy was 5 over 2gs, and the final energy is 90. So we've now got an equation which we can now solve to find the value of s. So we're going to do 2 times 90, which is 180, divided by 5g. So if we work that out on our calculator, we're going to get 3.67. And normally we give our answers to 3 significant figures, which is 3.67 meters. Okay, so this has been a video to help you show you how to find the length of a slope using energy equations. I hope you've understood, and I thank you very much for watching.